In Lab 3 Progress Check, we implemented code that stores our items and categories in MongoDB collections. And this week for Lab 3 Final, we're going to implement code that reads information back out of the database at program startup and also stores any changes to the data that the user makes through the user interface. So in terms of design, I think it's worth spending a minute thinking about the way this is implemented. So when you're adding a database to a system, you have a couple of major design choices based on how you expect the system is going to be used. So the biggest decision you have to make is whether you're supporting a single user working with the data one at a time, or whether you're supporting a multi-user environment. And the reason that's important is because it has an effect on how often you need to go to the database to check the underlying data. So in a single user system, or in a system where you have a server that has sole access to the data, anytime you change the information, you can update the data in the database and also update the data in memory. But you can be pretty sure that the data won't change out from under you, and that if the user asks for the same piece of data again, the version that you have in memory is going to be accurate, and so you can return it. But if you're in a multi-user system where either multiple users or multiple servers are touching the data at the same time, that allows the possibility for the version of the data that you have in memory to differ from what's actually in the database at any point, because somebody else might have written the data and you don't necessarily know that they've made that change. So supporting a fully multi-user system, multi-application system where multiple applications can change the data at one time makes the problem significantly more expensive, because basically every time the user wants to access a piece of data, you have to refetch it from the database to make sure that the version you have is the most recent version. And then you can try to save bandwidth by putting things like timestamps on all your changes and keeping track of when you last accessed the data, to make sure that like if you know that the data was changed before the last time you accessed it, then you don't need to reload the data. You just need to reload the timestamp. So that's actually quite a bit more complicated. And so what we're going to do in this class, and this will work both for the console-based version of the app and also for the web server-based version that we're going to implement later, is probably the most efficient way of accessing the data, which is when the program starts up or the web server starts up, you're going to fetch everything that's in the database, and it's going to be a small amount of data. I mean, you're not going to have multiple gigabytes of data here. So you're going to fetch everything from the data and you're going to cache it in memory. And then you're only going to go back to the data base when the user makes a change that you want to persist. So it's basically a read once model and then update many times as the user makes changes. And this will work fine as long as we make sure that only one server or user is changing the data at a time. And so if you have one web server that everybody's accessing that has one database behind it, it doesn't matter how many users you have because everybody's going to go through the same web server. So let's look at the Lab 3 final requirements with that in mind, and they're actually pretty concise. So we're going to implement the backend for our item manager program. So we already have the data stored in the database. We're going to add methods this week that read the information from the database, and also that add new items and categories, add items to categories, remove items from categories, deleting categories, and updating items. So basically all of the menu options that we had last week that actually changed the data, we're also going to add calls to the database that update the persistent storage. so that when you restart the program, you get all of the latest and greatest stuff. And so on startup, the complete state of all your current items and categories would be read from the MongoDB database. And every time the user makes a change, the new or updated information should be written to the database. So that might sound complicated, but it's actually fairly simple and will result in a fairly small amount of code being added. So the structure of the project is the same as last week. We're going to add some additional methods to the database class and also some hooks in our logic classes that call the functionality in the database. And then you're just going to zip the folder up and submit it.